Everybody is able to see the screen okay?
Yep.
Yeah, very good. Yeah, Owen, over to you.
Well, thanks, everyone. So my name is Dr. Owen Hinchy. I'm a lecturer at the University of Limerick in digital manufacturing and automation, and I'm also the course director for the new Equipment Systems Engineering Masters and postgraduate diploma. So I'm just going to run through a bit of background, a bit of a drive for digital manufacturing at the University of Limerick, and then I'm also going to talk about some of the action items we've been working on as part of this project. So I suppose in the University of Limerick, there's a big push towards developing digital talent. So if we look at the graph here, we can see that traditionally with Industry 3.0, we had likes of mechanical and electronics, which are really big, but that's now, I suppose, ballooned out into mechatronics. So some of the highlights at the University of Limerick from a mechatronic and digital manufacturing standpoint include, so we have a postgraduate in mechatronics engineering. That's been going since 2016, and I'll talk about that as I go through my presentation. We've got a ESC, so Equipment Systems Engineering, Industrial MEng. We've got a new professional diploma, which is kicking off now this September. We've got confirmed structured PhD. We've got a Marie Curie Smart 4.0 co-fund. Of course, there's this Erasmus Smart Edu 4.0 program as well, which is also very important to us. And there's a few other things as well. So if I just talk about, I suppose one of the major things is that we recently acquired funding for a SADI chair. I don't know where that laser is coming from. Okay, I'll keep going anyway. Okay. So we recently got funding for a SADI chair. So SADI chair is a senior academic leadership initiative. So again, it's about bringing, I suppose, female representation into the university at very high level, so at a professor level. Sorry, there must be timings on these. So I'll go on to the next slide. So Confirm is a smart manufacturing research centre that's run out of the University of Limerick as well, but it's actually spread across many different RPOs or research performing organisations. So you can see on the map of Ireland there, we've got NUIG, we've got TUS and Shannon, of course, University of Limerick, MTU, where we're here today, UCC, Tyndall, and so on. So this is I suppose, a across Ireland project. So we do a lot of research in terms of smart manufacturing, cyber physical systems, digital twin, AI, machine learning, data analytics, augmented reality, virtual reality, and so on. So this is a huge asset from a smart manufacturing research perspective. But one of the challenges we're finding here is that we're finding it difficult to get talent. So that's students going into from, I suppose, undergrad into masters and PhDs who have the necessary skill sets. And that's why I suppose the Smart Edu 4.0 project is so important, because it's about developing students with that talent. In terms of the Confirm Centre, so we recently opened our state-of-the-art headquarters. So this is just a photograph here of some of the equipment that we have on site. So we have the likes of robots, 3D printers. Not only are we academic based, but we're also linked to industry as well. So you can see on the top right of the image there, we've got J&J's industry testbed as well. So there's a huge amount of, I suppose, interest and buzz in terms of digital manufacturing and mechatronics. Recently, last year, we launched the UL at Work scheme as well. So it's a human capital initiative, and I suppose that's designed at, I suppose, developing skills and skill sets for those in industry and developing skills for people going into industry as well. So that starts off at a micro credential level. You can see on the left there. So that's like where you take one or two modules that are specific to what you're doing. And then you can, I suppose, build up these micro credentials into a professional diploma. And then you can build up your professional diplomas then and get awarded a master's degree if you get 3 professional diplomas. So this is just a structure of the new engineering degrees that we're pushing through as well. And I'm going to talk about the mechatronics undergrad degree that we're looking at. So you have the option of a BE, which is a 4-year, or an ME, which is a 5-year. But I suppose one of the big differences here is that the co-op placement, so that's the industry placement, that's actually being increased from 9 months to 12 months. And we're definitely getting demand signals from industry that they want it even longer. So we're even looking at the opportunity of maybe a 15-month co-op placement. So that's something that's being driven through UL at Work. So to take a step back and look at Smart Edu 4.0 and I suppose University of Limerick tasks. So there's 3 main tasks here that we were looking at. So one was scoping and market research of mechatronic courses that are out there related to the project partners. The second then is the development of undergraduate and postgraduate taught programs in manufacturing mechatronics, and I'll talk about the mechatronics course we have at the moment at UL. I'm going to talk about the ME course we're developing in digital mechatronic engineering, and then the third, I suppose, task that we were set with was the new CPD programs in smart manufacturing. So with that, I'll talk about the Master's Apprenticeship in Equipment Systems Engineering, and also the new professional diploma in Equipment Systems Engineering as well. So if we just look at the project partners, so we've got NTUA, Queen's, CERC, and UL here. So I suppose listed for NTUA are actually the modules related to mechatronics rather than the courses, but you can see that there's plenty of modules there. I'm not too sure in terms of what the courses are though on that. At Queen's, at the moment, there's no undergrad or postgrad in mechatronics. In CERC, there's 4 that kind of link in, and you can see them there in the table. And then at UL, we have the M-Engine Mechatronics, the M-Engine Equipment Systems Engineering, the Professional Diploma, and ESE Equipment Systems Engineering. And then we're also looking at developing an undergrad there, but I didn't include it on my slides yet because it's not a live course. So if we look at the postgrad course in mechatronics, so I lecture on this mechatronics masters. So it's done over 3 semesters. So we've got our autumn, we've got our spring and our summer, and essentially we've got some core modules. You could see them there for autumn: low cost automation, automation system design. They're about my modules. We've project management to practice. Then in spring, we kick off the mechatronics project 1, also digital control, global business strategy, machine vision. And then in the summer then, which is at the moment, they're kicking off mechatronics project 2. So in the mechatronics project 1, they could, for example, be building a cell like the one you see in the bottom right-hand corner there. So in project 1, they look at developing the virtual system, the PLC code, and that kind of stuff. And then in the summer, then they have the opportunity to actually work hands-on with the equipment. And then they have the option of taking one of 2 paths. One is the automation path. So we've got advanced and emerging manufacturing technologies, automation and control. And then in spring semester for path A, automation, we've got 3D modeling and machine design and system integration as well. And then path B then is IT based. So you've got the likes of computer networks, C++ programming, web-based application design, and real-time systems as well. Funnily enough, this year students, only 1 student took path B and 30 students took path A. So there's a real kind of desire to follow the automation route, which I think is quite interesting. So it's a 90 credit course as well. Just on the graph on the bottom right there, you can see the numbers of the course. So we can see that the numbers are really growing from when the course was launched back in 2016. We had 8 students, and then that steadily increased. And we do have I suppose an okay female representation, but we really want to improve that. So like this year there was, I suppose, just over 10%, and we're going to grow that. So we're pushing in the School of Engineering with the Athena Swan, and I suppose action items out of that to help promote females in mechatronics.
The numbers here are for the postgraduate?
No, the numbers here are for the students enrolled on the mechatronics master's taught program.
Masters.
Yeah, the mechatronics master's taught program. Yeah. Okay. So then I suppose building on our knowledge from the taught program, we're looking at pulling together a undergraduate course in mechatronics. So this is going to be an integrated kind of BE, ME, so it's a 4-year or 5-year, both with a May finish. So you have the opportunity to take your BE after 4 years or continue on to get a Master's of Engineering after 5th year. It's going to be workplace based, so there's going to be an extended co-op program. And as part of that, the students will actually be doing some blended lectures while on co-op, so they'll still have that link back to university. The plan is it's going to be a common entry through LM116. So LM116 is, I suppose, omnibus engineering at University of Limerick. At the moment, LM116 is like design manufacturer, or there's mechanical engineering, or there's biomedical engineering as well. So this will be a new exit route for that. And we're looking at developing state-of-the-art mechatronics labs as well, and we can also link back into our COFIRM headquarters. And again, a strong industry links with that, like the Stryker, J&J, and so on, are informing this course. And then finally, just to move on to, I suppose, the more recent work we're doing on new CPD programs in smart manufacturing. So these are programs designed for people who are based in industry to essentially improve their qualifications. So there's 2 here. There's a Master's Apprenticeship in Equipment Systems Engineering that was launched just last September. So we have our first cohort now in that, and we're looking to take on our second cohort now this coming September. And out of that, we've spun a professional diploma in equipment systems engineering as well, which will be kicking off in September. So just to give you an overview of the master apprenticeship, so it's a 2-year program. Again, the students are based in industry. It's a level 9 MEng, and it's essentially being led by the ISSC eCubers consortia. Or the consortium, but they're the consortia lead. So eCubers are a part of SL Controls, who are a company that do a huge amount of automation engineering for the likes of J&J and other big medtech companies, and they're seeing a real demand coming from industry for certain skills, and there are skill gaps there, and that's why they're keen on developing this. eCubers were also behind the development of the mechatronics masters in 2016 as well. In terms of the master's apprenticeship, 70% is on the job learning, so you're working on projects on the job, and 30% is either on campus or online, and the students work at approximately 15 hours per week on their projects. Just in terms of the structure of the 2 years, so year 1 starts at a boot camp, then there's a module on disruptive innovation sprints, and we'll talk about that in a few slides' time. And they put together their research proposal, and that's a proposal based on a project that they're working on industry. So, for example, one of my students, he's looking at, he's working for a company that makes stents, heart stents, and he's looking at developing a framework for doing essentially imaging of micro barcodes and essentially looking for defects as well. So that's one example of a project. Then we've got technology provider sprints, so that's in the second semester of year 1, and that looks at the different technology providers out there like Rockwell, B&R, Siemens, that kind of stuff. Then the students produce an ESC research plan, and then there's a project review at the end of year 1. Moving into year 2, then there's E-Expo, where they, I suppose, outline their innovation of what they've done the first year and their plan for the second year. And then they have their 3 stage gates in terms of their thesis. So as part of this, we've got the students, we've got the academic supervisor then that I suppose gives information on technical writing, lit review, academic research, and essentially completing the thesis. But because these are very, very specialized projects, we don't have an expert on everything. So what we have is you've got their industry mentor, and the industry mentor, their role really is to, I suppose, provide an enabling capacity in the workplace to help the student complete the project and give advice on it. And again, the idea is that they're going to be an SME, so they'll have subject matter knowledge on the project. So this is an example of some of the industry sprints. So that might be quite small to see there on the screen, but essentially what we have here is we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different topics. E stands for equipment. So, for example, the very first one there is e-digital transformation. So that's essentially the transformation of equipment into, I suppose, the digital world. E anywhere, so equipment anywhere, and equipment anywhere. So that's the likes of kind of this concept of factory in a box. So you have your equipment in a container and you drop it on site somewhere to make a certain thing. E-compliance, for example, equipment compliance. It's very important for regulated environments like medtech and pharma and so on. So that's some examples there. So from that then, what we've done is we've taken the modules from the ESC Masters and we've developed a professional diploma based on that. So this is a 1-year program taught over 2 semesters, starting this semester or this September. And it's going to be a formal level 9 professional diploma. And again, the ESC are driving this, but this is going to be delivered 100% online. So essentially, again, you've got people who are based in industry, engineers and so on, and they'll be working on the modules and the assignments, but there won't be a project associated with this. And then this is just my final slide. So in terms of the ESC professional diploma then, so there's 2 semesters, autumn and spring, and there's 3 modules in each. So one is the disruptive innovation sprints. Automation system design then is actually a mechatronics module that I lecture, so that's going to be put in there, but it's going to be delivered again in a blended format. And then we've got our digital futures lab in semester 1, and then in semester 2 we've got our technology trajectory strategy. So again, that talks about the technology and the hardware that's used. We've got system integration again, so that talks about standards like ISA, S88, 95, and so on. And then again, we got our digital futures lab. And then very small there on the bottom, this is essentially the structure of how it's laid out. So essentially, we've got 12-week modules. They're broken into fortnightly sprints that we call them, and each sprint is based on a certain topic. The students will have synchronous lectures, synchronous masterclass, so it's going to be 1 hour per week. So with the first week of the topic, they get their lecture. The second week is a masterclass where we pull someone in who's an expert in the area, whether they be from the university or from industry. But also, I suppose, the synchronous delivery is supplemented by asynchronous videos. So the idea, the structure is that we have, I suppose, 3 to 4 10 to 15-minute videos that the students would look at beforehand. Then they'd attend the live lecture, and then that lecture will also double as a discussion section. So typically you'd have a half-an-hour lecture followed by half-an-hour discussion and Q&A and so on. And then there's a SWOT analysis as a deliverable for each one of the 6 sprints you see here. And then that SWOT analysis at the end of the professional diploma can go back to the company, and that shows value because you're giving the student-based industry exposure to all these different things, and they can look at it and see, well, how can this add value to my company? So that's it in a nutshell. Does anybody have any questions on any of that? Yeah.
I just have one
Yeah.
Very quick question. In terms of the entry requirement for the professional diploma,
yeah,
and the apprenticeship, what is the minimum entry requirement?
So there's a 2-2 is a minimum entry requirement, but there's also the option to recognise prior learning. So, for example, there could be somebody who's been working for 10 years and they're an expert, but they may have only got, I don't know, they might even have a degree, but they have that experience. So again, you will look at that and just compare the learning. So I think it's 5 years on the job experience is the equivalent that we see.
What kind of jobs? It has to be like very much related to Industry 4?
Not Industry 4. So essentially, it's manufacturing-based engineering roles really we're targeting. So again, that could be process engineers. It could be, I suppose, technicians as well, to upskill them to, I suppose. So with the PD, you don't come out with, I suppose, an engineering qualification to call yourself an engineer. With the master's, it's an engineering degree.
Yeah.
But again, it's for people who are working on the site on a particular topic and they want to just kind of upskill. We were also looking at maybe offering it the PD to like some managers and so on to kind of give them exposure to these new technologies coming down the line and how they can be applied to their manufacturing.
Thanks a lot. Okay.
That's great. Thanks very much.
Thank you very much. Yeah, so